Alright, 12 is pretty tricky, so um, let's see how clearly I can explain this. So let's try to draw this first. And we have a mass A at the origin, a mass B out here. That's 30 degrees. And the net force is that way on A. And this angle is 16.2 degrees. That's not given. I figured it out because they said that the angle, the force was actually at an angle of negative 163.8 degrees from the positive x-axis. So that's this way, negative. So that makes this 16.2. And so I'm just going to draw this, the triangle that this makes for the components. So we got the net force, F net, we got Fx, and we got Fy. And they gave us the net force, 2.77 e to the negative 14 newtons. So if this is 16.2, it's pretty straightforward to figure out Fx and Fy. It's just sine and cosine. So Fx is cosine. This times cosine 16.2, so that becomes 2.66 e to the negative 14 newtons. And Fy, turns out that's sine of 16.2 times 2.77 times the hypotenuse. So that turns out to be 7.73 e to the negative 15 newtons. So we got that. Now, here's the deal. Let's just think a little bit about what the force due to C would have to do to get this net force. So first off, B is pulling A over to the left and up. Alright? And so if the net force is also over to the left, well, we actually have two options for C, depending on whether this net x component is larger or smaller than the x component for B. Let me just find the component, the x component of B real quick. And that will become more clear. So we have to calculate the actual force of B. And we need the components anyway, so we'll just do it. Fbx is G. The mass of B is 0.012. The mass of A, because this is the force between A and B, B is attracting A that way, and A is 0.006. I converted from grams to kilograms, and the distance between these, this length they gave in the problem was a half a meter, 0.5. Don't forget to square, happens so many times. And then we want the x component, so that's going to be cosine .30. So that equals, I didn't write it down, so I'm going to calculate it after I pause. So it equals 1.92 e to the negative 14 newtons. That is less than this. So in order to get all of this, we need some more pointing to the left, right? Because this is f net x, which means it's the sum of fbx and fcx. And since fbx is less than that, fcx has to go that way. So we know, let's just sketch it over here, that fcx has to point that way. Okay, now fcy, that's more straightforward. We don't have to actually calculate, because if the net force is down and fbx is up, then fcx has to point down. In fact, it has to not only point down to cancel out b, but then it has to go down this much more. So fc is going to go in that direction somewhat. So the particle must be, when we get our final answer, because we're looking for the x and y component of the position, no, sorry, the x and y position, we know that it must be over to the left and down in order to pull A that way. Alright, so without further ado, let's continue on doing that. So what makes this tricky is we really have to find the actual force and then break it into components. That's the only really way to do it. So let's do that for f net x. That's going to be fbx plus, as I discussed, fcx, because again fbx is less than the net, so they have to add together. So that's going to equal 1.92 e to the negative 14, just calculated that here, plus, and this is going to be C has a mass of 0.008 kilograms, A is the same as before, 0.006, over some distance, d squared, that we don't know, and this component, we're going to call this theta, some unknown angle, and the x component is cosine of that, so cosine theta. So two unknowns. And by the way, the f net x is right here, so that's gonna do that. Let's do f net y. We're gonna need a little more room for f net y because I didn't already calculate fby. So let's do this. Let's start it way over here. Whoa! F net y equals this, 7.73 e to the negative 15, and that's going to equal fb. Actually, if we're going to call f net y positive and f net and fy is down, then that means down is positive. So let's be consistent with that, and so that's going to mean, that means fcy is going to be down, positive, and fby is going to be up, negative. So that's just G, and C has a mass of 0.008 and 0.006 over d squared sine theta. So that's this guy right here. We don't know the theta, and we don't know how long this is. So we're going to keep both those as variables. Oh, system of equations. Look at that. Minus G times 0.012 times 0.006 over 0.5 squared. Basically the same as this, except sine 30. Alright, so from here, bunch of crazy algebra, and we're at 9.5 minutes, so I'm going to skip all the algebra. Basically, we got a number here equals a number here. This is a number, we know everything here, so we can add this over here, basically solve for d squared in this equation, solve for d squared in this equation, and set those equal to each other because d is equal. So then we can solve for theta. So basically d squared equals d squared. So the d squared for the y equation equals the d squared for the x equation. Solve for theta, crazy algebra, and you get theta is 60.13 degrees. That's this angle here. Go back in, plug theta into either of these equations, solve for d, and you get d equals rounded to 0.4 meters. And then we can go back if well, this is forced, but we can use this. Well, I'll just redraw the triangle here. D dx dy. We know this is 60.1 degrees. We know this is 0.4. So we do SOHCAHTOA. Dx is 0.4 cosine 60. So dx is 0.4 cosine 60. I'm rounding like crazy. And that equals negative, because it has to be over, here's the origin, so it has to be over this far. So negative 0.2. That's our position for the x position. Dy equals 0.4 sine 60, crazy rounding, and that's going down in the y direction, and that's 0.35 meters. So these are our two answers. So what to take away from this is when you're dealing with multiple forces that you're trying to combine into a net force, find the actual force first using the actual distance between the two objects, then break that up into components. Don't try to find components first. It'll screw you up with the whole squaring of the distance and everything. So that's really the main piece of advice, and yeah, so I hope this was pretty clear. Next problem.